In this project, we will be introduced to the Arduino Wi-Fi Shield for taking your project into wireless mode. We will learn about shields in general and how they extend the functionality of Arduino. Specifically with this project, we will learn how to connect to a network using our Wi-Fi Shield. The Wi-Fi Shield will form an important part of our online weather station, so we will also use it to connect to the Weather Underground Weather API to retrieve weather information in this lesson. Let's get started. Here are the objectives for this lesson. By successfully completing this project, we will have mastered the following items. You will be introduced to the Arduino Wi-Fi Shield and how it works. You will learn how to connect the shield to a network. You will also learn about the shield ecosystem in Arduino, and you will learn how to connect to the Weather Underground API, or Application Programming Interface, using the shield to retrieve weather information. If you are ready to begin, let's get this project started. Here are the parts we will need: an Arduino Uno, a USB cable, and the Arduino Wi-Fi Shield. Shields enable us to greatly enhance the base functionality of Arduino. Generally, they allow us to introduce new features or leverage otherwise complex functionality in our electronics projects. Here are some examples of shields that can help us out quite a lot in our projects. There is, of course, the Wi-Fi Shield that enables us to connect to Wi-Fi networks. This is what we will be using for this project. It enables us to make our projects wireless, and you can control them over the network or even the internet. There is also the GSM Shield that connects to GSM phone networks, which in fact we will be using to make our very own open source phone that can make actual calls and send text messages with the Arduino in another project. We can't wait for that one. The Motor Shield enables us to control several motors or even servos. And finally, the LCD Shield comes pre-built with buttons for creating navigation and a functional user interface. Essentially, a menu for your project that the user can interact with using the display. These are just a few examples of the many different types of shields that are out there, and with Arduino being open source, anyone can create a shield. The sky's the limit. If you create a great project with components that you think a lot of other makers will use, you can develop a shield yourself. The main concepts behind a shield are that they generally enhance the base functionality of Arduino boards like the Uno or Mega, etc., and they are connected on top of the boards, allowing access and a pass-through to the Arduino pinouts beneath. Many shields also come with third-party libraries predefined for them. In that way, you can easily integrate them into your projects and utilize code to interact with them without too many headaches. Let's go ahead and connect our Wi-Fi shield to our Arduino. So first, this is the Wi-Fi shield. As you'll notice, there are several long pins on the shield, and these are meant to connect directly on top of the Arduino. So in that way, when it's connected on top, you'll still be able to use the pins for your projects. So the shield acts as a pass-through for your pins and is meant to be placed directly on top your Arduino. So I'll go ahead and connect that now. You'll have to make sure that the pins line up. Alright, so there we go. So now as you see, the shield is directly on top of our Arduino, and of course you want to make sure that you line up the pins correctly, and pin 1 here is going into pin 1 on your Arduino. Now when we want to upload code to the Arduino and the shield, we just plug in our USB connection and we should be good to go. Okay, now I'm going to demonstrate how you can use your Wi-Fi shield to connect to a network. If you look at the Arduino IDE and you click on File, Examples, you should see some Wi-Fi sample programs here, and this really allows you to play with the Wi-Fi shield to get an understanding of how it can connect to networks, their different modes. If you have a WEP, a WEP network, you can use this particular sample program to connect with. If you have a network that has no encryption, you can use this one. I'm going to go ahead and select the Connect with WPA and open up that sample program, since this is primarily the most common type of encryption that we have on our home networks. So what you'll need to do is, once you connect your Wi-Fi shield to your Arduino, you'll need to put in the name of your network here. And I'm just going to turn the hotspot on my phone and connect to my phone network. So I'm going to write in the name of my network here. And of course, if you have the password that you need to connect to your network, you're going to enter that in here. So I just randomly generated that password. And I'll go ahead and do an upload. Okay, so once that's done uploading, as you'll see, I'll open up my serial monitor, and it would give you some status information as to how the connection is going. So right now it's saying it's attempting to connect to the network. You'll notice there's a delay in the program, but it is already connected, because if you look at the shield, that link LED is green. That means it's already connected. So as you can see on here, I was able to connect, and it gives me some information about my IP address and my MAC address for the actual Wi-Fi shield. What's the SSID, that's the name of the network that I connected to, and what the signal strength is and the encryption type. So some basic information. So it looks like I was able to successfully connect. Very, very simple, straightforward. I just needed to provide the network name and the password for my WPA network, and I was able to connect. Let's go ahead and review the Connect with WPA program for connecting our Wi-Fi shield to a secured WPA network. So at the beginning, we include a couple of libraries. We have the SPI library and the Wi-Fi library, and we're going to need a lot of components from the Wi-Fi library for us to interact with our Wi-Fi shield. You also have to specify, of course, your network and your password. So these are stored in these variables here, and you would put in the appropriate name of the network you want to connect to and the password that you need to connect to that network with. In our setup function, there is some boilerplate code, and a lot of this you will see repeated in the Wi-Fi program examples. So initially, here is where you attempt to connect to the network, and this is the main function here, the main line of code where we do Wi-Fi.begin. We pass in the network we want to connect to and the password, and this is where the magic happens. After we try to connect, we typically wait for about 10 seconds, so that ensures that everything with the connection is established and we are good to go. Once we're connected, you'll see you're connected to the network, and we call a couple of functions which tell us a lot about the IP address we're assigned and also the router that we connected to. So those are the print current net function and the print Wi-Fi data. So we'll just quickly take a look at those. In the print Wi-Fi data, here is where we retrieve the IP address that was assigned to us. So we do a Wi-Fi.local IP, and we're able to retrieve that IP address, and we simply display it out, as well as the MAC address of the Wi-Fi shield. So here is where we print that out. So you'll see that showing up on the serial monitor. In the print current net function, we simply print out the SSID of the network we connected to, as well as the MAC address of the router that we connected to. So that information is available, and we display it. Lastly, there's a little bit of information about the signal strength, so we display that out, as well as the encryption type. So very simple, straightforward, and this sample program allows us to connect to any WPA network. Let's take a look at the Weather Underground API, and I'll show you the process of registering for an API key. So I'm going to Google Weather Underground API, and here it comes up. And when you click on it, this would be the landing page. Just something to be aware of. The basic plan that we're using is essentially free if you go to pricing. So we'll be using the Stratus plan. It doesn't cost anything really, but something that you have to be aware of is that you're limited to 500 calls to the API per day and only 10 calls per minute. For the purposes of our weather station, we would not exceed that. We'd probably make about one call every 10 minutes in our program to retrieve weather information. So we should not go over this. But if for your application you need much more frequent updates, you probably would have to go to a paid, tiered plan. But for our intents and purposes, we'll use the free plan. We don't have to pay anything. It's just we have to make sure that we keep our requests under the quota per day. So, all right, so back at the home, you have to sign in to get started. So I'll go ahead and click on here. So if you don't have an account, here's where you'll need to sign up for Run. So you'll provide your email address, a username, and a password, and you click on sign up for free, and that would actually create an account for you, and you can log in. Since I already have an account created, I'm not going to sign up, but that's what you'll need to do to just sign up and create an account. So I'm going to log in. I'll click on here. So once you're logged in, you'd want to go to More and Weather API for Developers. All right, and this is your landing page around the APIs. So the first thing you need to do is generate a key, and this is the key you'll use, that API key, in order to make requests. So I'm going to go into key settings. As you can see, I already have an API key. I could regenerate one if I need to, but this is where you'll need to create your key. So you'll create an API key initially. There may be some information that you need to provide, project name. I just put Arduino Weather Station, the website. You can put your personal website there. And once you generate a key, you need to copy that key, and that's what you'll plug into the program that we'll need. So that's essentially the key registration process. I'm going to quickly talk about some documentation. So here's where if you want to see all the different features of the API, you know, there's quite a lot that's in here. We're just basically going to get the conditions. I'm going to click on conditions here, and it retrieves just weather information. So below here, as an example, you can get, this is what the web address or the URL looks like. Here's where you'd plug in your API key, and I take care of constructing this for you in the Arduino code, but just so that you'd get an idea, this is the response that comes back, and this is JSON. And JSON stands for JavaScript Object Notation. It's just a way for that servers use to send back data down to clients. That makes it easy to consume by web applications and RESTful services and so on. So here's the information that comes back about the particular city, and again, if you are an international person, you could provide that country information. So there you have it. So, right, so here you'll get details and weather information and so forth showing up here. All right, so that's the documentation. Feel free to look up some of the other features that you can get on here, but we're just going to use that conditions API. Okay, now we're going to connect to the Weather Underground API, and I'll show you how to retrieve the the raw weather information that is returned from the API. So just when you are running this program, there's a couple of things to remember. For the SSID, you'd want to put in the name of your home network or the network you want to connect to, and the password will be your password. Also in here, you'll need to change the API key. So you'll put in your API key. I will show you how to register for an API key from Weather Underground, so you'll need to plug that in here. And you can change the state and city appropriately for where you want to retrieve weather from. If you're in the US, you can put in that state and city. If you're international, for those of you guys who are taking this course internationally, I wanted to accommodate for you. So what you'll need to do is comment this out for US and uncomment these, and you can put in the name of your country and your city, and the program should still work. So let's first demo connecting to the API and retrieving the weather for Bloomington, Illinois. So I'll go ahead and do that now. Right, so it is compiling and uploading. All right, here's the serial monitor. So as you can see, it's attempting to connect to my Wet9 network, which is the hotspot on my phone. So I turn that on, and the program has a pause for about 10 seconds after it connects. Well, it is already connected, and then it's going to attempt to make that call out to Weather Underground. So there it is. It started the connection. It connected to the server, and we should see the results coming back now. All right, so that is the JSON that was returned from the server, and as you can see, it gives you a lot of information about the city, the latitude, longitude, and so on. And then we have some weather information here, what the temperature is in Fahrenheit, Celsius, the humidity, and wind strength and so forth. So lots of different types of information that is returned, weather related, very handy. And we will be using this information to extract the fields that we want to display on our LCD for our weather station. So just wanted to show you how this worked. For those of you guys who are outside of the US taking this course, I want to demonstrate to you how you can change that international location to put in your country and your city. So we're going to make a few modifications to our program here. I'm going to comment out the US information, and I'm going to uncomment out the international information here. And let's find the weather in Sydney, Australia, because that sounds pretty nice right about now. So we put in Australia and Sydney. You'll fill this in with whether that is appropriate for you. I'm going to go ahead and upload again. All right, so you'll notice it's attempting to connect to our network again. As I mentioned, there is a slight delay that we purposely introduce in our program to make sure that we successfully connect. Once we do, we'll get some network status information, and then we're going to connect out to the Weather Underground API. All right, so here we are connected. Now we're trying to retrieve the information, and there we go. So the result came back, and as you can see in that JSON response, we got information about Sydney, Australia, and latitude, longitude, and so on. And down here is the weather-related information. Looks like the temperature is about 65 degrees Fahrenheit, which sounds cool, but pretty nice. And there's some wind and pressure information and so on. So there you go. Any of you guys taking this course outside of the US, you should be able to retrieve weather information for wherever you're living to make the display show up your weather information. Let's take a look at the retrieve weather program. So this program uses the Wi-Fi shield to retrieve weather information from Weather Underground. And at the beginning, we've seen this previously where we include the libraries that we need, the network, and the password for the network we want to connect to. Then we set up our server. Here's where we put the API weatherunderground.com, and then we would specify our API key. So here's where you would put in that API key that you registered for on Weather Underground. You'll plug that in here. And as I mentioned, for folks that are in the US, you can put in your state and city, and that would retrieve information from your state and city. And for those folks who are taking the course who are outside of the US, international folks, you would simply specify your country and city. So you may need to tweak and try this out. I'm not sure if every available country and city may have weather information, but you can just try it out in the major cities that are around you, or you try your city and see if you get weather information coming back. Next in our setup function, this is all code that we've seen before. I'm not going to go over it. I've discussed that previously, where we attempt to connect to the network. And once we're done, here is where actually the magic happens. This is where we make the HTTP request to the Weather Underground server. We have to construct the URL that we're requesting the information from. I try to make it easy for you, and basically here we would plug in the API key and weather location that you would have entered at the top of the program, and it generates the URL request for you. We make that request to the host, which is API weatherunderground.com, and that essentially makes the request. In our loop function, once the client is available, we do a read. So this is when the server is sending us information, sending information back down the wire. We read those characters that are sent back and we display it in our serial monitor. So that's how we were able to see all the details that were coming back from our server. Just a quick thing that I wanted to mention here is in this particular program, we are acting as a client, a Wi-Fi client. So because we are retrieving information from a server, and that server is the Weather Underground API server. So we're acting as a client. There may be some other examples where you'll see that you can set up an actual server for your Wi-Fi shield. Those, when you go through the examples, you'll see the different modes. But in this case, we're acting as a client requesting information from a server. To summarize, in this project, you learned about shields and how they extend the functionality of base Arduino hardware. You were also introduced to the Arduino Wi-Fi shield and how it works, and used it to connect to a network. We connected to the Weather Underground API to retrieve weather information using our Wi-Fi shield. By understanding the concepts of the Wi-Fi shield and how it connects to networks, you now have the knowledge to make your projects wireless. We will be completing our online weather station in the next project.